Okay, welcome back, and now let's do another example of linear and angular speed. So in this case we're going to find both. And so in this case we've got a wind turbine. Okay, so again you could draw yourself a picture, but you've got a wind turbine with these propellers, right, that go around in a circle. And what they're telling us is that the blade of one of the blades of the wind turbine is 116 feet long. The propeller rotates at 15 revolutions per minute, or RPMs, revolutions per minute. Okay, so they give us those two information. So the first thing is this is the radius, right? So 116, so that's our R, and they're giving us this speed here. Okay, and it's angular, but it's not telling us, it's not angular speed. So we've got to take this here and we've got to change it into angular speed and into linear speed. Okay, so let's start with angular speed. So omega, right? Omega is what? It's the angle, changing the angle over time. So it's going to be how much has the angle changed over time. Okay, now what does this tell us here? It's 15 revolutions per minute. So we just need to change this into an angle. Right? So 1 revolution is 2 pi. Right? So 1 revolution on the circle is equal to 2 pi radians. So that means the angle here, right, theta, the central angle for this is going to be what? 15 times 2 pi radians, or 30 pi radians. Okay, that's it. So now we got our central angle. So now we can just plug and chug. So it's going to be 30 pi radians over 1 minute. Which means it's just going to be 30 pi radians per minute. And we're done. Now the linear speed, now the linear speed, we can go ahead and use the velocity, right? Or excuse me, the other formula, we could use this, right? V equals arc length over time. Which is equal to r theta over time, right? So then we can plug this in, so we know theta now, right? So r is 116, and then theta is 30 pi, and then time, excuse me, is 1 minute, right? Because we already know that it's per minute, because it's revolutions per minute, right? So this is going to be per 1 minute. Okay, now if we put this in our calculator, it's going to be approximately equal to 10,933 minutes. Or excuse me, 10,933 feet, right? Because this is feet. right here, 116 feet. So feet per minute. But there's another way that we could have done it, because remember the formula that relates linear velocity to angular velocity. Okay? So we could use that formula too. And that would work just as well. Right? So radius is 116 times what? What did we get? 30 pi radians per minute. Right? But remember, radians is unitless, right? So we get the same answer. We would get the exact same answer, okay? Either way. All right, cool. Make sure you practice.